Alright, so in this problem we are given two forces, F1 and F2, acting on a 4 kilogram disk that slides over frictionless ice. And on this surface we are laying an XY coordinate system. Let's make a sketch here of this disk and the surface on which it's sliding. So this is our surface, this is our disk, and the force F1 is pointing in the positive direction of the x-axis and has a magnitude of 7 newtons. So we can draw our force F1 here, and we know that its magnitude is 7 newtons. The force F2 has a magnitude of 9 newtons, and we have no idea of its direction actually. So we are also given this graph of the x component Vx of the velocity of the disk as a function of time t during the sliding. And the question is, what is the angle between the constant directions of forces F1 and F2? So we are supposed to deduce this angle from the graph that we are given, the magnitudes probably of these forces, and some equations, of course. So first of all, from this graph that we can see here of the x component of the velocity versus time, the first thing we can deduce from this graph, first of all, is the acceleration. We can see that the velocity is a straight line increasing with time, increasing linearly. So we can deduce that the acceleration can be found from the slope. And this acceleration, of course, will be the x component of the acceleration, not the total acceleration of our disk, since the graph is for the x component of the velocity. So this is going to be equal to the slope, which we can calculate from this graph. So we can just take any 2 points. I'm going to consider this point here. This is 0, minus 4. And this point here, which is 3, 5. And I can deduce the graph. I can deduce the acceleration from the graph. Okay, so we got the value of the acceleration. What we're interested in is the angle. But to find the angle, let's consider Newton's second law, which applies in this situation, which says that the sum of forces is equal to the mass times the acceleration. And let's apply this to the x direction. Now, along the x direction, we have f1x plus f2x equals max. The x component of f1 is f1 itself, since f1 is along the positive x direction, while f2, we have no idea what its direction is, but we know that f2x is going to be f2 cosine the angle it makes with the horizontal. So we got this equation, and in fact, if we check this equation, we can see that we are given all of the values of the different variables here. We are given the value of f1, f2, the mass, and the acceleration. So we can deduce cosine theta from this equation. So we can first rearrange this equation. Cosine theta is going to be max minus f1 over f2. So if we substitute the values that we are given here, the mass is 4 kilograms. We found the acceleration to be 3 meters per second squared. F1 is given to be 7, while F2 is 9. So if we solve this, and then we're going to get 5 over 9, and we can deduce theta. And this will give us 56 degrees. Now this angle is going to be the same as the angle between F1 and F2. This angle is the angle that F2 makes with the horizontal, but F1 is along the horizontal. So this is the angle that F2 makes with F1 as well.